Alright, here we go. So, simplifying these as much as possible. We're going to multiply inside to inside. So that equals, square root of 14 times 7. And what's 14 times 7? Well, it's 98, but I don't care, because all I would do with that 98, if I did multiply it together, would be to break it down into its multiples again. Alright, so now I've got my 3 factors there. So this is equal to the square root of 7 times 2z. And there is a pair of 7's here. So that means I take out 1 7 for every pair under the square root, and that gives me 7 root 2. Done. For this one, it's easier to think of it as like a root 5 over a root 9. It's because 9 is one of those special numbers that you should remember. Square root of 9 is 3. Alright, so I didn't have to do anything clever with the denominator like I have to on the next one. Alright, so 7 is not a perfect square, so I can still think of it as root 3 over root 7. But now I've got to rationalize the denominator. What that means is I multiply the top and the bottom by the same thing, and that same thing is exactly what the bottom square root is. That way I get square root of 7 times square root of 7 equals plain old 7. Boom. And then this is a root 21, and you can't simplify that anymore. If this was more simplifiable, like if I multiplied this and it ended up that there were more factors in here, right? If I divided it, it's just a 3 and a 7, so there's no pair of numbers. Or there's no perfect square that goes into 21. But if I multiplied it and then it gave me a number that was more simplifiable, I would have to simplify it. Alright, so now we multiply the outside times the outside, and then the inside times the inside. But actually, this one, they're both root 7. So root 7 times root 7 is just going to equal 7. And then 3 times 4 is 12. So I have 12 times 7, which equals 84. Bam. Alright, so see this guy here? We've had one of those ever since we taught you how to multiply radicals. There's been one of those on every worksheet, every exit quiz, every quiz, test, whatever. So I'm thinking you'll probably see one of these on the final too. What I'm going to do is, you got to remember that this little exponent here means I multiply this thing by itself twice. So really I need to think of it like this. 5 root 3 times 5 root 3. Multiply the 5s gives me 25. Multiply the root 3 times root 3 gives me just a plain old 3. 25 times 3 is 75. Here, multiply the outside times the outside gives me a 6. And I don't want to actually have to multiply these together. I can break down, because 45 times 20 would be 900, but then I would just break that back into the numbers that multiply into it. Alright, so we have a 3 and a 3 and a 5, and then if I break down 20, that gives me a 4 and a 5, so it's a 2, and a 5. So this 5 comes from the here. That gives me times 5 times 2 times 2. And then I now have these different pairs of numbers. A pair, and a pair. And then that, pull out 1 2, pull out 1 5, pull out 1 3. And that gives me 6 times 3 times 5 times 2, which is 180. Alright, so now we have to rationalize the denominator. We've got to multiply by root 10 over root 10. So it gives me 5 times root 10 on the top. Do not multiply these, because that's an outside and that's an inside, so I can't multiply those. And then it's over a plain old 10 on the bottom. Now, I can actually reduce those. Come on. So, 5 goes into that once and 5 goes into that twice. So I have 1 root 10, or just plain old square root 10, over 2. There's the answer for that one. Alright, now there's several ways to go about this. I'm going to go about it the more efficient way. So I can think of this as multiply inside times inside, so that's like the square root of 10 times 27 over 9 times 5. And now I'm going to cancel all the stuff that is cancelable. So 9 goes into that once and 3 times. 5 goes into that once and twice. So it's really just the square root of 6 over the square root of 1, which is really just the square root of 6. Final answer there.